Hello and welcome to Math with Mrs. Becker. Today in pre-calculus, I'm going to show you a really cool way that you can solve inequalities using graphing technology. What we are going to use is Desmos.com. Okay, so I'm just going to jump ahead. Today we are just looking at 5 examples, okay? If you want to go ahead and find out what x values I could fill into this inequality where this side would have a value that's greater than this side. One thing you could do is go on to a graphing utility and graph this function and then also graph this function and see the x values where this graph is above, meaning it's greater than this graph. However, my favorite way is to go ahead and get one side equal to 0 because then you can use the x-axis, and I'm going to show you that trick today. Okay, so if I go ahead and I want the set equal to 0, I need to take this polynomial function and subtract it over. But what we want to do is be able to keep them separate. So on Desmos, I will say, okay, I had x to the power of 4 plus 10x cubed plus 21x squared. That's my first polynomial function. Then I'm going to minus over 40x plus 80. That would have to be greater than 0. So I can put this into Desmos.com and I want to look at this one graph. It's just going to be one function. I want to see where the x values are greater than 0. So I can actually use the x-axis. So let's do this. So I'm going to have my first function was x to the power of 4 plus 10x to the power of 3 plus 21x squared. Close the parentheses, minus, I went ahead and subtracted 40x plus 80. Okay, so what I see is this. Well, obviously this means I'm gonna have to set my window. I do notice that I'm having like plus 80 and that sort of thing. So I know that those are my vertical translations. So I'm going to go like negative 100 to positive 100. Okay, now here I can see the graph. So this is what it is. This is the graph of this side. We want to know when this is greater than 0, meaning when is it above the x-axis? So that happens at 2 different spots. Remember that interval notation we were talking about? This goes forever and ever. So it's negative infinity all the way to here. The x value is negative 1.53. That's when it's equal to 0. So it goes up to negative 1.53. I'm rounding it because I don't want to include it. I don't want to include it because that would be if it was greater than or equal to. So this means anything to the left and all the way up to that x value, if you fill those values into the original, you get a true statement. Now this is below. We want to know when it's greater than. So again, starting at 1.892, all the way up to the right, all the way up to infinity, this is where you would go ahead and have x values that would make this true, because on the graph, those are the x values that are above the x-axis, which has a value of 0. Super fun. Okay, let's look at another one. Again, I want to get the set equal to 0. Now this one, it's just one single number, so I can go to x squared plus 3x minus 4 is less than or equal to 0. Now this time, we want to know when it's less than or equal to 0. So not knowing what the window is going to do, I'm just going to hit that home. Remember, that gets you back to a standard window. I am putting in 2x squared plus 3x minus 4. I want to know when it's less than or equal to 0. That means when is it below the x-axis or even equal to? Well, here are your 2 values. So remember that interval notation, here we go. That interval notation that we talked about at the beginning of 2.5, the lower value to the bigger value. Where does this start? And this would be squared because it can include it because it's less than or equal to 0. So negative 2.351 up to and including 0.851. So any value in between here and those values, that's when your function is less than or equal to 0. Let's look at another one. Okay, now this time I am moving a full function. So I have 2x to the power of 4 plus 3x cubed minus, I'm going to take this whole thing, 2x squared plus 4x minus 2 is less than 0. Okay, so I took this and I moved it over. I have to put this in here, and I want to know when it's less than 0, meaning below the x-axis. All right, let's go ahead and delete this. I'm just going to keep my window as standard for now just to see. Open a parenthesis to x to the power of 4 plus 3x to the power of 3. Go ahead and close the parentheses. Then I subtracted a polynomial function over, so I'll put that in parentheses. 2x squared plus 4x minus 2. If I close it, I want to know, I'm going to go ahead and zoom in a little bit here. I want to know when this is less than 0, meaning when is it below the x-axis? So if I go ahead and tap on those zeros, this is when it is 0. So it's below, in between those two. So that interval notation at 0.5, but it doesn't include it, that's where it starts, all the way up to 0.8398, and it's 8393, there we go. And it's rounded because it doesn't include it. We don't want to include the zeros, but the values in between these two values, that's where the graph is underneath the x-axis. So it's below. All right, let's look at another one. It's just one little term, so let's add that over. X squared plus 8x plus 20. When is this greater than 0? Okay, so when is it above the x-axis? Let's go ahead and get rid of that. X squared plus 8x plus 20. When is this above the x-axis? All the time. So this would be negative infinity to positive infinity. Any x value is above the x-axis. No value from that parabola is ever even at 0, nonetheless below it. So negative infinity to infinity is the fancy way of saying all real numbers. Any x value would keep that graph greater than 0. Last one. Again, I'm going to take this polynomial function and subtract it over. So I had x cubed minus 2x squared minus 5x plus 7 minus the group 2x plus 1. We want to know when this is greater than or equal to 0. So let's go ahead and get rid of this function. I just got my screen back to the home screen. X to the power of 3 minus 2x squared minus 5x plus 7. That was the first polynomial function. Then we moved 2x plus 1 over to the other side. So here's the graph. Okay, I'm going to kind of zoom this in a little. That's pretty darn good. I can see everything. Okay, perfect. Okay, I'm just going to keep it. So if I look at this, I want to know when it's greater than or equal to 0. Well, there's two little intervals here. This is all greater than or equal to 0. So, and it includes it because it's equal to, so it's a squared bracket, negative 2.264. It's above the 0, all the way till you get here. It hits 0 again, 0.756. Okay, so that is where it includes those points. And this is where it's above 0. Then this is below, so it doesn't count. Then here it hits 0 again. So at 3.508. Now this, notice it goes forever and ever and ever and ever. This is a situation where it goes to infinity. It's going to keep going to the right. Infinities are always rounded. So looking at interval notation, where we could find values that would make our original inequalities, so they are true statements. The cool thing is, though, if you can get them set equal to 0, you get to use the x-axis. If it's less than, you want to know when it's below the x-axis. If it's greater than, you want to know when it's above the x-axis. So today was just a notes day, just showing you something really cool. I hope you had a fun time learning something new, and I'll talk to you soon. Bye.